Hey everyone, in this video let us understand the math intuition behind linear regression. Before jumping into the video, let us understand what linear regression is and how it actually works. So let us consider a data set that has experience and salary, and we have the data points like this. So in linear regression, what we try to do is we will actually try to draw a best fit line between the data points such that the distance between the best fit line and the data points is minimum. So our goal is to reduce the distance between the data points, and the equation of the line is given by y equal to mx plus c. As we all know, this is the equation of the straight line where m is the slope of the line and c is the intercept. Here you can understand slope as change in y-axis with respect to change in x-axis. Here, unit change in experience will result in significant change in salary. So this is what slope is. In linear regression, how to decide which line is best suited for our model and how to choose the best fit line. In order to understand this, you can draw multiple lines between the data points and decide which line with a particular slope that is well suited for your model. So we have to choose a line that has a slope such that the distance between the line and the data points is minimum. That specific line is called a best fit line, and it is used to predict accurate values. In order to understand this, we can use a function called cost function. What cost function actually says is that we have to reduce the distance between the best fit line and the actual line. In simple terms, the best fit line actually contains the predicted values. The best fit line contains the predicted values such that the distance between the predicted values and the actual values is minimum. This can be given by the formula like cost function is equal to 1 divided by 2n summation of I equal to 1 to n y cap minus y the whole square, where n is the number of data points and y cap is the predicted value and y is the actual value. Here the points that are present in the best fit line are the predicted values, and n is the number of data points, total number of data points that we have in our data set, and y is the actual data points. To understand the cost function, consider a graph like this where y is equal to x. So when the value of x is equal to 1, the value of y will also be 1. Here we will consider the equation y cap is equal to mx plus c, and consider the m value to be 1. So here we can see that the line passes through the origin, which implies, consider this as origin, which implies the value of c equal to 0 because it is the intercept of the x-axis. So considering the data points for different values of x, the predicted value will be 1 into 1 plus c, where c is actually 0. The value of y cap will be 1. When x is equal to 2, y cap will be 1 into 2 plus 0. The value of y cap will be 2. And when x is equal to 3, y cap will be 3. So now let us apply this to our cost function. What cost function actually says? 1 divided by number of data points. So here let us consider we have 3 data points and summation of y cap minus y the whole square. What it actually says is that for all different points of x, we have to calculate the predicted values. Here our y cap is same as the x values. So I'll be putting 1 minus 1 the whole square plus, here this for the second point we have the same value as 2. 2 minus 2 the whole square, and for the last point we have 3 minus 3 the whole square. So our cost function will be 1 by 6 into 0, as all the differences are 0. We will be getting our cost function as 0. So what we will do is we will try to find the cost function that is minimum. But how do we say that this is actually minimum? It is not, right? So what we have to do is we have to try for different slopes. We will have to find for slopes with m equal to 0 0.5, m equal to 0, m equal to 1, m equal to 1.5. For that, we have to calculate for different values. So let us consider m is equal to 0 0.5. So if we take m equal to 0 0.5, we will be getting y cap values like y equal to 0 0.5 into 1 plus c equal to 0 0.5, and for x is equal to 1, y implies 0 0.5, and when we take x is equal to 2, we will be getting y cap as 1. So we might be getting a best fit line like this when m value is 0 0.5. We will be getting a line like this. So for different m values, we will be getting different lines that will be having different slopes. Hence, we can get multiple lines with different slopes in our data set. So now we have to find which line is best suited for our prediction. So intercept value will, here it is 0, but in our data set that we are using, it will definitely not be 0. It will be having intercept somewhere in the y-axis. So here comes the important part. So now we have to find which slope we are going to use and which is the optimum one. So let me take a new board to explain this. So in order to find the best fit line with a particular slope, what we are going to do is we are going to plot the different values of slope with their cost functions. For example, we took value of m is equal to 1, and further we might have taken the values of m equal to 0 0.5, 0, 1.5, 2, etc. Right? So we are going to plot these values with their cost function values that we got from the formula. The formula is 1 by 2n summation of 1 to n y hat minus y the whole square. These values. So if we plot them, we will be getting a graph like this. 0, 0.51, 1.5, 2, 0.51, 1.5 and 2. We will be getting a graph like this. This is not an accurate graph. Consider it as an example. So here we will be having the minimum value, that is the minimum error. This particular value is called as global minimum. Why it is called as global minimum? Because the cost function is less. That implies the error between the best fit line and the data points is minimum at this point of the particular slope. Here we will be mapping slope in the m-axis and the cost function values. Let us consider it as y of m. So this particular value is called as global minimum. In this value, the error will be minimum between the best fit line and the data points. This is an important part of this cost function and the linear regression. This particular graph is called as gradient descent graph. Gradient descent. In this graph, you can see that the graph is reducing here and the value of the graph is increasing here. There is a particular reason for this to happen. This is given by a theorem called as convergence theorem. Convergence theorem. What this theorem says is that it says that we have to find the derivative of the slope with respect to the learning rate. So let me explain it. The convergence theorem is given by slope is equal to slope minus derivative of slope with respect to m multiplied by learning rate. So what this actually says is that here we can see that the value of the slope is getting reduced. So this is called as a negative slope. And here we can see that the value of the slope is increasing with respect to the cost function. So we can say this as a positive slope. So if we take a derivative of the slope, consider the left side where the slope is negative. and we have a learning rate of 2.5. So say that the value of the m is 2.5. So what this convergence theorem says is that we have to take m minus the value of the slope will be negative. In this particular point, here it is reducing. So the derivative of the slope value will be a negative value. m minus, m minus negative value multiplied by a small learning rate. So consider the value of the learning rate to be 0. There is a specific reason for the learning rate to be a small value. So what here it happens is that here we have taken a slope value of 2.5, so it is a positive value. So what convergence theorem says is that this has a positive value and it must be reduced. So minus into plus will be minus and that should be multiplied by 0.01 learning rate. So what it says is that it has a positive value and the value needs to be reduced in order to get the global minimum. So the value of m will be multiplied with learning rate such that the value of the m will be reduced furthermore. The same the vice versa happens for the negative slope. It says that the slope is negative. We have to increase the value of the slope in order to reach the global minimum. This is what convergence theorem says. In simple terms, we are reducing the value of the slope if it is high, and inversely, if the value of the slope is reducing, we are trying to increase it. This is what the convergence theorem actually is. There is a reason for learning rate to be small. Here we can see that there are small steps we are seeing that the gradient is descending. If the learning rate is too high, consider it to be like this. If the learning rate is too high, there might be chances that the slope will tilt here and it comes back and it goes back like here. Since the learning rate is very high, it cannot reach the global minimum and there are chances it might never reach the global minimum. Hence, it is necessary to reduce the value of the slope eventually. If the learning rate is too high, the system will understand different values for m and it might jump to different places instead of reaching global minimum. In this case, our data set has only two features, that is experience and salary. If the number of features is more, then this gradient descent would be have multiple dimensions. For example, here experience and salary we are considering only two features and we can represent as two dimension. Suppose in case we have three features, this gradient descent will be in three dimension. It will look something like this. Here you can see it is a three-dimensional graph. So that global minimum value with respect to learning rates will be something like this. At the end, it will reach the global minimum point. If in case in our data set has four features and we have to visualize, it will be difficult. And in some cases, it will go to multiple dimensions, which will be hard to display. This type of multiple dimension gradient descents will be only present in multilinear regression, where we will be considering many features with different intercepts that will be hard to visualize. Here we have taken only two features and we can easily represent them in a two dimension, and three-dimensional features will also be visualized using specific libraries in Python. So now let us jump into the practical explanation of linear regression. Here I have imported the necessary libraries and I have read the dataset using pandas. Here we have experience and salary. Now I need the experience to be a whole number and salary that contains only two decimal places, so I have formatted that using pandas. So now we have the dataset ready. So now we have an interesting concept called correlation. Correlation is nothing but it gives the change in the dataset with respect to features. Correlation is a statistical measure that quantifies the degree to which two features change together. The most common method for measuring correlation is Pearson correlation. Here, defaultly it takes Pearson correlation as its parameter. So here I have given a data.correlation for our dataset. Usually the Pearson correlation ranges from -1 to 1. The positive one indicates it is a perfect positive linear relation, and negative one indicates it is a perfect negative linear relation, and 0 indicates no linear relation. Here we can see that it has 0.81 and 1, and it has 81 as 1. So it says that if one feature increases, the other feature also increases in positive linear relation. Here we are both values are positive and it has positive relation. That means if one value increases, the other also increases. As experience increases, the salary also increases. So it is necessary to check features before we start to design any model. So now let us visualize our data. Here we can see that our data is linearly increasing. So we can confirm that from correlation and visualization that our data is linearly increasing and it is best suited for linear regression model. So now let us jump into the trend test split of our dataset. Here I have splitted the data where the test size is 25% and I have given trend test split and imported linear regression, and now I am creating the model and I am fitting the data, and I have used metrics and accuracy. If you want to know more about metrics and accuracy, I have discussed this about in my previous video. You can check there. Now let us visualize the regression line in our model. So now I have drawn the best fit line in our model. The red line represents the best fit line that is chosen by sklearn library automatically. Here, all these hyperparameters are chosen by sklearn itself. If you want, we can alter them. But here we didn't give any slope values or learning rate or m values, anything like that. What sklearn does is that it internally calculates all these values and provides the best fit line automatically for us. This best fit line is most suited such that the data points are at a minimum distance from the predicted values, that is the values present in the data line. If you want to visualize the gradient descent graph that has cost functions and slope values, we have to design a linear regression model without using sklearn. As sklearn as all the operations and that is being done internally, it is not possible to get all these values and visualize them. We cannot visualize the gradient descent here because sklearn's linear regression uses another method for linear regression optimization called OLS, ordinary least squares method. If we want to use gradient descent in scikit-learn, we have to use another method called stochastic gradient descent or implement linear regression without sklearn. We will use both these approaches in the upcoming videos. Now we can get the slope and intercept of the best fit line. This model.coefficient gives the coefficient, which is nothing but the slope of the line. Here we are able to get the slope of the line as 0.84. So the equation of this line is y equal to mx plus c, and the value of m is 0.84. And model.intercept gives the value of c, which is the intercept of this line, and intercept as the value of 0.94. So now we are able to generate the best fit line with the slope and intercept values using linear regression of scikit-learn. These values might change if we add or remove the data points from the dataset, as the line tends to move with the slopes with respect to the distance between the data points and the best fit line. So here are some important notes to remember. Always check for correlation between features. If two independent features are highly correlated, then we can choose either one of them. But here we have only two features, and one is independent feature which is experience, and another feature which is a dependent feature, that is salary. So if you have many features, check for correlation between them, and if two features are highly correlated, we can take any one of them because it does not impact the result that we are going to generate. As the features are highly correlated, they will be similar, so it is better to choose any one of them. This concept will be understood when we go through feature engineering. And always remember to keep the independent features as a 2D array or a data frame, which will be helpful during trend test split and another operations in independent features. So in this video, we understood the math intuition behind linear regression and implemented a practical model to understand that. So let's create a linear regression model without sklearn and also using stochastic gradient descent in the upcoming videos.